Hello everyone, welcome to our first topic about hot stuff. So today's learning objective is you need to know what is endothermic reaction and what is exothermic reaction. You also need to relate temperature change to endo or exothermic reaction. You need to draw energy diagram for both endothermic and exothermic reaction. You need to tell me what is the unit you will use to measure energy. And what does a plus and a minus sign mean in energy values? Okay, here we go. Some background information is that what are the different kinds of energy? So we know that, okay, when you're running, you are using kinetic energy. And here's an example of a light energy. When two chemicals reacting with each other or several chemicals reacting with each other, when they produce new chemicals, that's called chemical energy. Here's something else that we have is heat energy. So when you have ice melting, then you're absorbing heat energy. And when you have something boiling, then you're releasing heat energy as well, right? You can feel it's getting hot. So heat energy and chemical energy, those are the two things that we're going to talk about today. Another background information is that reactant are the things that react together during one reaction, and the product are the things that's being produced during one reaction. So for example, in here I have a carbon react with oxygen that produce carbon dioxide. So whenever you're looking at one equation, for example, this chemical compound equation, the plus, usually you read it as react with, and this long arrow thing, you use it to say produce. So in here you have say carbon. I know it's a carbon because I look at my periodic table. And I know this is oxygen because I look at my periodic table as well. So carbon react with oxygen that produce your carbon dioxide. So let's go back to our first learning objective. We need to know what is endothermic and exothermic reaction. So what is endothermic reaction? Well, it is something that involves with heat energy and chemical energy. So basically the heat energy will enter into the system and transfer into chemical energy. So let's take a look at it. Endothermic, it enters into the system, right? For example, when you're having an endothermic reaction, you need those energy going to your chemical, all those compounds, to have your chemicals get it going and then change into something new. You need those heat energy, basically. So therefore, the heat energy enters into your system and transfers into chemical energy to get it going. So you need the heat energy to get the chemical reaction going. For example, you have cool packs in the summer, right? And also when you're doing sports, sometimes you injure yourself, you need something to be able to cool instantly to make yourself feel better. So basically, if you kind of crush those cool packs, you can feel it's getting cooler and cooler, but how does that work? Basically, we have some chemical reaction happening here, but to get it going, they need heat energy. And they absorb those heat energy from your hand to make the things going, right? That's why you feel cooler, because your heat energy is being taken away. So the surrounding usually feels cooler because the surroundings heat energy is being taken away into those chemical compounds. And the temperature will go down when you measure it because you feel cooler, and the same thing goes with thermometer. Thermometer feels cooler and temperature will go down. Just pretend we have some little chemical reaction happening here, and their endothermic reaction, to get them going, they need heat energy. So they took away all the chemicals, take away all the heat energy from the water or whatever liquid is surrounding them. In general, the solution will feel cooler. That's why your temperature is going down. And then, what is an exothermic reaction? We talk about endo is enter, then what is exo? You can look at it as the energy exit the system. So you have your chemical energy change into your heat energy. For example, you have combustion, which is an excellent example of a chemical energy change into heat energy, or burning things, right? If you start to get it going, then the chemical energy will start changing to heat energy. That's why you feel so much warmer after that. So the surrounding feels warmer because when the reaction happens, all the chemical energy inside of those chemicals, they change into heat energy magically. That's why you feel warmer on the outside. And therefore, the temperature will go up when you measure it. So look at this beautiful match. When you feel it, it's warmer, right? Because it's an exothermic reaction. Energy exits the system. One example in our daily life is salt. So when you have a sodium metal react with chlorine gas, that produces our table salt. So this is one chemical reaction. So Na is our sodium. I know that because I look at my periodic table. Cl is chlorine. In here, some people ask, what is S? What is G? S basically means it's solid. G means it's a gas. So sodium metal usually is in the solid form. React with my gas chlorine that produces my sodium chloride, which is also called table salt. The energy will exit the system. Therefore, it is a exothermic reaction, right? You will feel the beaker gets warmer and the temperature will go up. That's our table salt. And also, you need to draw a graph for exothermic reaction. What do I mean by a graph? Well, here's what it looks like. So on the x-axis, it is our progress of reaction. Basically means that as a reaction goes, what does it look like? And the y-axis is our energy. In here, the energy means specifically chemical energy in here, right? So exothermic, the chemical energy the heat energy exit out, right? You have less chemical energy because they change into heat energy and then they run away from you. Therefore, your energy level will go down because you have less chemical energy in here, right? They all change into heat energy and the heat being released. So the reactant is like here. There's a thing that reacts in the very beginning, and then you produce your product. Therefore, you will have less chemical energy because they're all changing to heat energy, right? On the other hand, endothermic reaction, your stored chemical energy will go up because you're getting all those heat energy and transforming into your chemical energy. You're building things up, and your product, which is what you have in the end, will have more chemical energy than your reactant because you're getting all those heat energy, changing them into your chemical energy. So now let's take a break. Are these reactions endo or exo? Burning paper is an endo reaction or exo reaction? Exothermic reaction. So burning paper, you feel warmer, therefore it is an exothermic reaction. Cool pack, it is an endothermic reaction. One reaction, the temperature goes down when you measure it, that is a endothermic reaction. Now, two more things to talk about today. Exothermic reaction, here's one example. Iron react with sulfur, produce iron sulfide. The energy changing here is minus 100 kilojoule. Two things that need to be noted in here. First thing is a minus, second thing is a kilojoule. The kilojoule means that's a unit of this energy change. We usually measure energy change using kilojoule. How far it is to take you to go back home, you use minute or hour or second. How far your home is from your school, you use kilometer, meter, right? In here, the unit for energy is kilojoule or joule. And the second thing is minus. Minus means that it's going down, right? And this dog is going down. Therefore, it means that you have less energy than before. Think about the minus, you're subtracting things, you have less things. Therefore, your energy is exit out of your system in the form of heat. Therefore, this is your diagram. Therefore, it is an exothermic reaction. Same thing goes with endothermic reaction. If the exothermic is a minus, it's going less, the energy is less. What about endothermic reaction? One example we have, an energy change is a plus. Because you're getting more energy, think about plus, you're adding things up. You're adding the energy into your system. Okay, let's go back to our learning objectives. See if you know all these stuff. Firstly, do you know what is an endothermic reaction and what is an exothermic reaction? Can you relate temperature change into endo or exothermic reaction? Can you draw energy diagram for endo and exothermic reaction? Can you state the unit used for measuring energy? Can you say what is a positive and minus signs mean in energy values? Thank you guys very much and see you guys in class.